Hello everyone, my name is Tanmay. I am from Sri Venkateswara College of Engineering, Bangalore. Today I am going to discuss about data integrity attacks in cloud computing. These are the contents which I am going to discuss. Let us start with the introduction. Cloud computing has become an integral part of modern day businesses, offering scalability and cost effectiveness. However, with increasing cloud adoption, data integrity attacks have also increased. Data integrity attacks can compromise the reliability, accuracy, and consistency of data stored in the cloud, leading to significant financial and reputational losses for organizations. This presentation aims to explore the various data integrity attacks that can occur in cloud computing and their impact on businesses. Data integrity attacks in cloud computing refer to a type of cyber attack in which an attacker maliciously alters, deletes, or destroys data stored in a cloud-based system. Cloud computing has become increasingly popular in recent years due to its scalability, cost effectiveness, and flexibility. However, the use of cloud computing also possesses significant security risks, including data integrity attacks. In cloud computing, data is stored in remote servers owned and maintained by a CSP, that is known as Cloud Service Provider. The cloud service provider is responsible for ensuring the security and integrity of the data stored in the system. However, attackers may attempt to exploit vulnerabilities in the cloud service provider infrastructure or the cloud-based applications to gain unauthorized access to the data and compromise its integrity. Moving on to the objectives. To identify the different types of data integrity attacks that can occur in cloud computing, to understand the impact of these attacks on businesses, to explore the existing solutions and techniques used to prevent and detect such attacks, to propose new methods to enhance data integrity in the cloud. Then our next topic is literature survey. These are the three papers which I have referred for literature survey. First paper is a survey of data integrity attacks in cloud computing by S.S. Grewal and S.K. Danda in the year. This was published in the year 2019. This paper provides a comprehensive survey of data integrity attacks in cloud computing, including types of attacks, detection and prevention mechanism, and existing research work on the topic. In this paper, the advantage is this paper provides a comprehensive survey of data integrity attacks in cloud computing. It's covering various types of attacks, detection and prevention mechanisms, and existing research work on this topic. This makes an valuable resources for researchers working in this field. And the disadvantages of this topic is, while the paper provides a comprehensive overview of data integrity attacks in cloud computing, it does not offer in-depth analysis of the various attacks or their implicits of cloud security. This may limit its usefulness for researchers who require more detailed information. And coming to next paper, this paper is all about preventing data integrity attacks in cloud computing using blockchain technology by ND Town, NH Tran and NQ Trang in the year of 2020. This paper proposes a solution for preventing data integrity attacks in cloud computing using blockchain technology. The authors use a distributed ledger to ensure data integrity and propose a consensus-based algorithm for detecting and preventing attacks. In this paper, the advantage is by using a distributed ledger, the proposed solution ensures data integrity in a secure and transparent manner. This can increase trust and confidence in cloud computing services, which is critical for organizations that rely on these services. The disadvantages of this paper is, while blockchain technology may be effective in preventing data integrity attacks in some cloud computing scenarios, it may not be applicable or practical in all solutions. This may limit the usefulness of the proposed solution for some organization. And the third paper is all about data integrity attacks and detection techniques in cloud computing. This is a review by S. Sharma and P. Kumar. This was published in the year 2020. This paper provides a review of data integrity attacks and detection techniques in cloud computing. The authors discuss various types of attacks and their detection methods, including signature-based, anomaly-based, and hybrid approaches. The advantages of this paper is, the author discussed multiple approaches to detecting data integrity attacks, which helps in understanding the strengths and limitations of different techniques. The paper highlights the importance of data integrity in cloud computing and the need for effective detection mechanism. And the disadvantages of this paper is, the paper may not cover all types of data integrity attacks or detection techniques, as new attacks and methods are constantly emerging. And the paper does not provide a comparative analysis of different detection techniques which could help in determining the most effective approach. Then let us discuss about the types of data integrity attacks. There are several types of data integrity attacks that can compromise the integrity of data stored in computer systems, including those in cloud computing environments. Here are some of the most common types. Malware attacks. Malware attacks involve the use of malicious software such as viruses, worms, or trojans to infect a computer system and modify, delete, or corrupt data. Malware can be introduced into a system through email attachment downloads or by exploiting vulnerabilities in software. Man-in-the-middle attacks, that is known as MITM. Man-in-the-middle attacks involve intercepting data transmissions between two parties and altering the data in transit. Attacker can use man-in-the-middle attacks to modify or delete data or to inject their own malicious data into the transmission. SQL injection attacks. SQL injection attacks involve exploiting vulnerabilities in web application to inject malicious SQL commands into a database, which can result in unauthorized data modification or deletion. Fileless attack. Attackers use techniques to exploit vulnerabilities in software to gain access to system memory and modify data without leaving a trace on the hardware. Ransomware attacks. Ransomware attacks involve the use of malicious software to encrypt a victim's data and demand a ransom in exchange for the decryption key. If the victim refuses to pay, the attacker may threaten to delete or publish the stolen data. Insider attacks. Insider attacks involve employees or other trusted insiders who intentionally or unintentionally modify, delete, or corrupt data. These attacks can be difficult to detect and prevent as insiders often have legitimate access to data they are compromising. Physical attacks. Attackers can physically damage or destroy hardware that stores data such as hard drivers, servers, and network devices. Overall, data integrity attacks can take many forms and can be perpetrated by a wide range of attackers, from sophisticated cybercriminals to insiders with legitimate access. It is important for organizations to be aware of the various types of data integrity attacks and to implement appropriate security measures to prevent and mitigate them. Then methods, coming to methods of data integrity attacks, data ingestion, data extraction, and data modification. These all are the methods that attackers may use to carry out data integrity attacks. Here is the brief introduction of each method. Coming to data ingestion, this is a type of attack in which an attacker inserts or injects unauthorized data into a system or a database. For example, if an attacker may use SQL ingestion to insert malicious code into a web application, allowing them to modify, steal, or delete data. Another example is when an attacker inserts malware into a system through a phishing email or a compromised website. Then moving on to data extraction. This is a type of attack in which an attacker steals data from a system or database without authorization. For example, an attacker may use a packet sniffer or intercept and steal data in transit, or they may exploit a vulnerability in a database to extract sensitive data such as passwords, credit card numbers, or personal information. Then data modification. Data modification is a type of network in which an attacker alters or modifies data in a system or database without authorization. For example, an attacker may modify the value of a bank account balance or change the contents of a file on a server to disrupt operations or cause harm. To prevent data ingestion or extraction and modification attacks, it's essential to implement security measures such as access control, intrusion detection or prevention systems, and encryption. Additionally, regular vulnerabilities assessments and penetration testing can help identify and address vulnerabilities in systems and databases that attackers may exploit. Coming to consequences of data integrity attacks, financial loss can occur due to disruption of business operations, system downtime, or loss of revenue. Legal implication may arise due to the violation of regulations, data breach notification, or lawsuits. Reputation damage can occur due to the loss of trust, customer dissatisfaction, or negative publicity. Coming to prevention measures that can be taken for data integrity attacks, first one is data encryption. Data encryption is the process of converting data into a code that cannot be easily read or understood by unauthorized users. By encrypting data, you can protect it from being accessed, modified, or stolen by attackers. Encryption can be done at different levels such as disk, file, or data at rest encryption, and can also be used for data in transit such as network traffic. Coming to access control is the practice of limiting access to data and resources to only authorized users or groups. This can include using strong passwords, multi-factor authentication, and role-based access control to ensure that only those who have a legitimate need to access the data can do so. By implementing access control measures, you can prevent unauthorized modifications or deletions of data. Then third one is regular monitoring. Regular monitoring and auditing is the practice of keeping a close eye on your systems and data to detect any signs of suspicious activity. This can include setting up intrusion detection systems, reviewing logs and audit trails, and using automated tools to monitor for unusual patterns or behaviors. Regular monitoring can help you identify data integrity attacks early on so you can take action to prevent further damage. Auditing involves reviewing and analyzing your system logs and other data to ensure that your security controls are working as intended. This can help you identify vulnerabilities and gaps in security measures and take corrective action before an attacker can exploit them. Overall, data integrity attacks can be very damaging to organizations, and it's important to implement a multi-layered approach to prevent them. By using encryption, access control, regular monitoring and auditing, you can help protect your data from unauthorized access, modification or deletion. Detection techniques for data integrity attacks. There are several detection techniques that can be used to detect data integrity attacks. File integrity monitoring, that is FIM. FIM tools monitor file systems for changes to files, directories and other system components. They can detect changes to system files or data files that may indicate a data integrity attacks. Next is intrusion detection system, that is IDS. IDS tools monitor network traffic for signs of suspicious activity such as unusual network traffic patterns, unauthorized access attempts, or attempts to modify or delete data. Then security information and event management, that is SIEM. SIEM tools collect and analyze security event data from across the network, including logs from systems, applications, and network devices. They can detect patterns of activity that may indicate a data integrity attacks. Next, baseline monitoring. This baseline monitoring involves establishing a baseline of network and system activity and then monitoring for deviation from the baseline. Unusual activity may indicate a data integrity attack. Then database auditing. Database auditing involves monitoring database activity such as queries and updates to detect unauthorized or suspicious activity that may indicate a data integrity attack. The sixth one is digital signatures. Digital signatures can be used to verify the authenticity and integrity of data. If a digital signature fails to verify, then it may indicate the data has been modified, tampered within. By using these detection techniques, organization can detect data integrity attacks in a timely manner and take action to minimize the impact of the attack. Moving on to mitigation strategies for data integrity attacks. Data integrity attacks are a type of cyber attack that aims to modify, delete, or insert false data in order to compromise the integrity and accuracy of information. To mitigate the impact of data integrity attacks, there are several strategies that can be implemented. Incident response plan. An incident response plan is a documented set of procedures and guidelines that an organization can use to respond to a data integrity attack. It typically includes steps to take in the event of a breach, including how to identify and contain the attack, how to notify stakeholders and authorities, and how to restore system and data. By having a well-defined incident response plan in place, organization can minimize the impact of a data integrity attack and respond more quickly and effectively. The next one is data backup and recovery. Data backup and recovery is the process of creating and maintaining copies of important data in a secure location and being able to quickly recover the data in the event of a data integrity attack. This can include backing up data to an offsite location or cloud-based storage, as well as regularly testing data recovery procedures to ensure that they work as intended. By having a robust data backup and recovery strategy in place, organization can minimize the impact of a data integrity attack and quickly recover from any damage. And the next strategy is cyber security awareness training. This educates the users and other stakeholders about the risks and best practices associated with data security. This can include training on how to identify and report suspicious activity, how to use strong passwords and other security measures, and how to recognize and avoid common phishing and social engineering scams. By promoting cybersecurity awareness and providing regular training, organizations can reduce the likelihood of successful data integrity attack. Overall, data integrity attacks can be very damaging to organization, and it's important to have mitigation strategies in place to minimize the impact. By developing an incident response plan, implementing data backup and recovery measures, and promoting cybersecurity awareness and training, organizations can reduce the risk of a successful data integrity attack and respond more effectively if one occurs. Moving on to conclusion, data integrity is essential in cloud computing as it affects the quality and reliability of the cloud services. Data integrity attacks can occur when attackers gain unauthorized access to a cloud-based systems or data and modify, corrupt, or delete critical information. Preventing and mitigating data integrity attacks in cloud computing requires a multi-layered approach that includes a combination of technical controls, policies, and procedures. This can include measures such as data encryption, access control, regular monitoring and auditing, incident response planning, data backup and recovery, and cybersecurity awareness. To ensure the integrity and security of their data in the cloud, organization must work closely with their cloud service providers to implement strong security controls and practices such as data encryption and regular security assessments. They must also ensure that their employees and other stakeholders are trained to recognize and respond to potential data integrity attacks. Research and development in data integrity protection in cloud computing should focus on enhancing security and privacy while enabling seamless and reliable cloud services. Protecting against data integrity attacks in cloud computing requires a combination of technical and non-technical measures along with a strong commitment to security and risk management. By taking a proactive approach to data security, organizations can reduce the risk of data integrity attacks and protect their critical information assets in the cloud. And this brings us to the end. I'd like to thank you for your time and attention today.